Hello viewers, this is Wagdaru now taking you through the story of A-level subsidiary mathematics, and this video we're going to talk about the topic of continuous probability distribution. So this topic is under the section of probability and is suitable for students in both senior 5 and senior 6 offering subsidiary mathematics as part of their combination. So a continuous PDF. So PDF is the short form of probability distribution function. So a continuous PDF is a function whose random variable, say x, takes on values within a given range. So it has inequalities. Can be x is greater than or equal to 1 but less than or equal to 3. So that is it means that this is a random variable and its function will be a continuous PDF. So this function allocates probabilities to all the ranges of values that the random variable can take. Remember, there are two parts of PDF. There is discrete and continuous. Now discrete takes on integers, whole numbers, but for continuous it takes on any number, as it can be a decimal point. If it's a decimal point, then it's under continuous PDF. But if for discrete, it is entirely whole number. For example, x, probability of x equal to 1, x equal to 2, but here it is an inequality. So you start with the first part, which talks about individual probabilities, and we shall say that this involves integrating. So each time you talk about continuous PDF, you have to talk about integration. Remember, for discrete, PDF are calculated by tabulation or tabulating the probabilities, but for continuous you have to integrate. So this involves integrating the given function for the given limits of the required probability. So they usually give you the limits, and the limits to use depend on the probability which is asked. So unlike discrete PDFs, for continuous PDF the inequality signs less or equal to and less than mean the same. So this is very vital. It's a distinction between discrete PDF and continuous PDF. For discrete, these symbols, these inequalities mean differently. For example, if they say x less than or equal to 3, it means that it starts from 2 and less, 2 1 0. But for continuous, x less than or equal to 3, x less than or equal to 3 means it is 3 2 1 0, and x less than 3 is 2 1 0. That is for discrete. But for continuous, x less than or equal to 3 and probability of x less than 3, they all mean the same. The same applies to also greater signs. So for example, x, the sign of greater than or equal to and the sign of greater than, they also mean the same. For example, probability of x greater than or equal to 3 and probability of x greater than 3, they are the same under continuous PDF. But for discrete, those two probabilities are different. So in this, because of this, it implies that for continuous PDF, probability of x greater than 1 but less than 2 is got by integrating from 1 to 2. Remember, we said individual probabilities are got by integrating, and the limits to use are in the probability which is required. So in this case, when they want probability of x greater than 1 but less than 2, you integrate from 1 up to 2, as you can see here. Similarly, x greater than or equal to 1 but less than 2, still you have to integrate from 1 up to 2. Why? Because for continuous, these two symbols mean the same. Think you realize that this is just less, this is x greater than, and this is x greater than or equal to, but they mean the same. Similarly, the probability of x greater than 1 but less than or equal to 2 is the same as probability of x greater than or equal to 1 but less than or equal to 2, because this inequality is the same as this inequality for continuous PDF. And all these probabilities are got by integrating from 1 to 2, because these are the boundaries. Think and see. For that is 1 and 2. This one is from 1 to 2. This one also 1 to 2. This one is 1 to 2. So all those 4 are got by integrating from 1 up to 2 of the given function. So this line is very, very vital. So before we go to any other concept, let's go through this question. So question 1 says the probability distribution function is given as this. So this is how they express continuous probability distribution functions. I think realize that we end with 0 elsewhere, meaning that a probability which is not in this given range must always be 0. So that's what that 0 elsewhere means. So they said they'll give you this PDF and they said find Roman 1 probability of x greater than or equal to 1 but less than 2. That is Roman 1. Then Roman 2, x is less than 1. So just start with Roman 1. So Roman 1, we have to remember the formula that the probability of x greater than or equal to 1 to less or equal to less than 2 is given by integrating from 1, because the smallest is the lower limit is what you put here, then the highest is the upper limit is what you put here of fx, and integrate with respect to x. So that means that you have to go to your function and look for that function fx. So in this question, the function of fx is a quarter x in brackets 4 minus x squared. So that is what you are going to substitute for fx. So we shall come and say that where there is fx, we shall put there this function. But remember, you cannot integrate when there is this product. So what you have to do, you have to first open brackets, bring this x inside, and also this one is a constant, a quarter, so it can also be taken outside. That is why in this other step, this quarter has been taken outside, and it's that. Then after that, we have to bring this x inside. So x times 4 gives you 4x. Then x times x squared gives you x cubed. So now we can integrate. Remember, the integration is by increasing the power by 1 divided by the new power. So you first leave this constant outside, and then we open brackets, then we start integrating. So 4x becomes 4x. The x is the x power 1, so you have to increase the power by 1 to come up with 1 plus 1, then divide by the new power, which is 1 plus 1, and that's why you see 1 plus 1 down in the denominator. Then this was x cubed, the power is 3, so you have to increase the power by 1 to come up with 3 plus 1, then divide by the new power, which is 3 plus 1. So after that, we are going to simplify. So 1 plus 1 is 2, that's why you see here 4x squared, and this one is also 2, that's why you see here 2 there. Then 3 plus 1 is 4, that's why you see 4 there, and 3 plus 1 is also 4, that's why you see 4 there. So with that, we have integrated. So next is to substitute the limits. Now in substitution, you begin with the upper limit followed by the lower limit. So upper limit, when I substitute 2 where there is x here and here, I'll substitute 2 to come up with this bracket. Realize that this is 4x squared becomes 4 times 2 to the power 2 over 2. Then x power 4 over 4 becomes 2 to the power 4 over 4. So I put that in its own bracket, then I subtract, I say minus, then substitute the lower limit. So where there is x, I'll be putting there 1 to come up with that bracket. So next is to simplify further. So 4 times 2 squared, that is 4 times 4, which is 16, divided by 2, you get 8. That is why you see 8 there. Then 2 to the power 4 is 16. 16 divided by 4, you come up with 4. That's why you see 4 there. Then 4 times 1 squared is 4 times 1, which is 4, divided by 2, you come up with 2. That's why you see 2 there. Then 1 to the power 4 is 1, divided by 4, you come up with a quarter. That's why you see a quarter there. Then next we simplify further. So 8 minus 4 is 4, that's why you see 4 there. Then 2 minus a quarter is 7 over 4, that's why you see 7 over 4 there. So next to simplify again, 4 minus 7 over 4 gives you 9 over 4, that's why you see 9 over 4 there. Then this a quarter still comes there. Now then I will multiply these two to come up with 9/16. So basically that's what they wanted in Roman 1. Now let's see how much can be awarded. So M1 for the definition of probability. So for you to substitute this, actually it's at that point where you show that this probability is equal to the integral from 1 to 2 of this given function. That's why you can get that M1. The another M1 is for integration, for you to integrate. Another M1 is for substituting the limits. Another A1 is for the final output. So this can be given in decimals, so for decimal places, or you leave it in fraction form. So leaving it in fraction form is the best option. So that was Roman 1. Roman 2, they said find the probability of x less than 1. So in this case they are giving us only one limit, x less than 1. What does that mean? X less than 1 means you don't exceed 1. It is 1 or less. So what do? You go back to your function and look at the given range of values. The smallest is 0. So this x less than 1 means that you start from the smallest, which is 0, and end at 1. So that is what x less than 1 means. If it was x greater than 1, it means that you start from 1 up to the highest. So in this case the highest is 2, so you would have integrated from 1 to 2. But in this case we are going to integrate from 0 to 1 of fx. So now we shall go to Roman 2, where they wanted the probability of x less than 1, means that you start from the smallest up to 1. So you are going to integrate through the given function fx from 0 to 1. So I'll come back and write the given function like we did in the previous part. In Roman 1, we have to first bring this x inside and put this a quarter outside. So that gives us that. Then we integrate as we did in Roman 1, but what has changed are the limits. So this is, in Roman 1 it was from 1 to 2, now it's from 0 to 1. So next is to substitute the limits. So I'll begin by substituting 1, which is the upper limit here and here, to come up with that bracket. Then after that I'll substitute the lower limit, which is this here and here, to come up with this bracket. The next is to use a calculator and simplify. So when I simplify, this gives me 2, this gives me a quarter, and the whole of this gives me 0. So in the end, 2 minus a quarter is 7/4, and this a quarter is still here. You come up, bring it there. So when I multiply in the end, I'll come up with 7/16. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for the definition of probability, M1 for integration, M1 for substituting limits, and A1 for the final output. So that has been part A for individual probabilities. Now we shall go to part B, which has total probability. So total probability, here what we need to know is that total probability is always equal to 1. Always remember that. What does that mean? It means that integrating all values of x, integrating fx for all values of x with respect to x must be equal to 1. And this is used to obtain the value of an unknown constant in a PDF. So sometimes they can give you a function which has an unknown constant. So in that case you have to remember that for you to get the unknown constant, you must use the condition that total probability is always equal to 1. Just like it is in this question 2. Question 2 says a probability distribution function is given as this, and they said find the value of the constant k. Now when they ask for the value of the constant k, what you should always remember is that total probability is equal to 1. What does that mean? It means that integrating fx for all values of x with respect to x must be equal to 1. So this function must never be forgotten. Now let's see how we can use this to find the value of the unknown constant. So the first step is to know that integral of fx for all x is equal to 1. Then after that we are going to substitute fx and also all x. Now what does that all x mean? So all x means But to look at this given function, what are the limits? The limits are 0 to 2. So in this case, these are the limits we are going to use. So we're going to integrate fx, which is this, from 0 up to 2. So let's come and write that. So that is what it means. Then, like I said, you can't integrate when there is a product here. So what we are going to do, we have to first bring this x inside. And because it's a constant, it can come out just as it is here. So you should remember that it has to be equal to 1. The next is to integrate like we did in the previous, in question 1. So increase the power by 1. So when I increase the power by 1 here, it becomes 4x squared, then divide by the new power, which is 2. Here, increase the power by 1 becomes x power 4 divided by the new power, which is 4. So the limits are from 0 to 2 and it's equal to 1. So next is to substitute the limits. So when I substitute 2 where there is x here, I'll come up with this bracket. Then after that, I'll substitute 0 where there is x to come up with this bracket. But it should be equal to 1. The next is to simplify. This gives me 8 and this gives me 4. Then the whole of this bracket gives me 0. So 8 minus 4 is 4. So in the end I'll come up, but remember there is k outside, so it becomes 4k equal to 1. But they want the value of k, so to make k the subject, I'll have to divide both sides by 4 to come up with k equal to a quarter. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for the definition of total probability, this equal to 1 must be seen. Then M1 for integration, M1 for substituting limits, and A1 for the value of k. So that has been part B, which involves total probability and helps us to get the value of the unknown constant. Now let's go to part C, which has mean. So another word for mean is expectation. So they can either say find the mean of x, or they can say find the expectation of x, or find the expected value of x. So all those three terms mean the same thing. So you come and say that the expected value of x is denoted as this. So they, instead of giving it in words, they can say find ex. So when you see this symbol, just know that they want the mean of x. So it can be denoted by this or this, and given by the formula that mean of x is equal to the integral of x fx. Not this word, it is x fx. It is a bit different from the one used for getting probabilities. So when you're getting probabilities, you only integrate fx. By this time, when they want the mean or expected value of x, you must integrate x fx. Always remember that. So we are going to see how this is used in the next slide. So part D, that is part C, then part D, we are going to combine these two and come up with one question. So part D says find the variance and standard deviation of x. So variance of x is given by the formula this. So this is var x, so this is also a symbol to mean variance, and it's given by the formula e of x squared minus ex everything squared. Now these two are different. In this part, the square is on x alone, and in this part, the square is on the entire ex. So note that difference and be keen with it. So we have already seen what ex is, so that this is what you put here and square it after. But the question is, what is ex squared? So ex squared, just like it is for this is the simple trick. Ex means that you integrate x fx. Then ex squared means you integrate x squared fx. I think you realize that this x squared, this is x squared also here, and this is x, this is x there. So that is a simple way to memorize the formula. So ex squared is equal to the integral of x squared fx with respect to x of all values of x. We shall see how these two formulas are used, how this is used, and also how this is used. So that was variance. Now standard deviation is the last parameter, so standard deviation is simply the square root of variance. So after getting variance over x, you just get its square root, and that square root will be equal to standard deviation. So now that we know the formula for mean, variance, and standard deviation, we are going to combine all those three parameters into question 3. So question 3 says the probability distribution function is given as, then they give you this is the function, then they say find Roman 1 ex Roman 2, so ex means expected value of x, then var x means variance of x, and lastly standard deviation of x. So you start with the Roman 1 of ex. So for you to do such questions, you must be able to remember the formula. So remember that we said the formula for ex means when there is x here you must include an x. That's a simple way of memorizing it. And remember, in the question our fx was given. So in this question, fx is a quarter x in brackets 4 minus x squared. So that's what we are going to substitute for fx. So this x is here, and this fx is the whole of this. But you're integrating with respect to x, so you have to put that dx there. So that dx must be seen. Then all x means that you go back to the question and look at the given interval. So when you go back to this question, you realize that the interval is from 0 to 2. Therefore, that means that you are going to integrate from 0 to 2, as you can see it there. 0 to 2. Okay, so next is to integrate, but before you integrate, you must remember that you can't integrate when there is this product. So what you're going to do, you are going to first put those x into this bracket. So what we do, we shall remember that x times x gives you x squared. That is why you see here x squared. But still, there is still a product. I think we see this is x squared, and also there is this bracket which has x squared. Therefore, what does that mean? It means that you have to put this x squared inside this bracket. This quarter is a constant, so it can be put outside the integral. So when I put it outside the integral, it is this quarter here. Then this one goes here to come up with 4x squared, and also this one goes here with this to come up with x power 4. Now that we have this, next is to integrate. Remember the rule that increase the power by 1, divide by the new power. So in this term, the power is 2. So when I increase it by 1, I'll come up with 3. Then divide by the new power, which is 3. For this term, the power is 4. Increase it by 1, I'll come up with 5. Divide by the new power, which is 5. Then I'll have to remember the limits from 0 to 2, so 0 to 2. Now that I've finished integrating, next is to substitute the limits. So I begin with the upper limit. So where there is x here, put there 2 to come up with this bracket. And after that, you say minus. Then where there is x, you put there 0 to come up with this other bracket. This quarter is still maintained. So next is to use a calculator. So 4 times 2 to the power 3 over 3 gives me 32 over 3. Then 2 to the power 5 over 5 gives me 32 over 5. Then the whole of this gives you 0. Then their quarter is still maintained. Then after that, I will use the calculator still. 32 over 3 minus 32 over 5 gives me 64 over 15. But this quarter is still maintained, so it will come there. The next is to multiply a quarter by 64 over 15 to come up with 16 over 15 as the expectation of x. So basically that's what they wanted in Roman 1. Now let's see how much can be awarded. So M1 for the definition of ex, then M1 for integration, M1 for substituting limits, M1 for the output. So that was ex or the mean. Now we shall go to var x or the variance. So you should remember that the variance is given by the formula ex squared minus ex everything squared. So we have already got this EX in Roman 1, but we don't know EX squared yet. So what we are going to do, we are going to first find the value of EX squared. So we know that when this is X squared, this is also X squared. So that is a simple logic for you to memorize the formula. So let's first get EX squared alone. So EX squared is given by the integral of X squared fx of all the values of X with respect to X. So I'll bring this X squared here, then this fx is the whole of this, which is a quarter X in brackets 4 minus X squared. Then the dx is still maintained. So that I'm going to multiply, so X squared times X gives me X cubed. That is why you see X cubed here. This a quarter is this a quarter, and this bracket is that bracket. So still we cannot integrate this because there is a product here between these two brackets, these two variables. So what we are going to do, we have to bring this X cubed inside, and this one can be put outside because it's a constant. So when I put this a quarter outside is this, then this one X cubed times 4 gives me 4X cubed. Then again X cubed times X squared gives me X power 5. Then this minus is maintained, it is there. Now next is to integrate. Remember the concept, increase the power by 1, divide by the new power. So this a quarter is still maintained there. Then for this term the power is 3, so increase it by 1, you come up with 4, then divide by the new power, which is 4. Then this term the power is 5, so increase it by 1 to come up with 6, divide by the new power, which is 6. So with that we have integrated. Next is to substitute the limits. So when I substitute, I begin with the upper limit. So where there is x, I'll put there 2 to come up with this bracket, and after that where there is x, I'll put there 0 to come up with this bracket. Now next is to use a calculator to simplify. So 4 times, first of all, this one and this one can cancel to remain with 2 to the power 4, which is 16. Then 2 to the power 6 is 64, which is there. Then this 6 is also maintained. Then the whole of this is equal to 0. Now next one is to calculate 16 minus 64 over 3 gives me 16 over 3. But this a quarter is 2 there, so you bring it here. Now next is to multiply a quarter by 16 over 3. First of all, this and this can reduce to give you this 4. So in the end you come up with 4 over 3 as your value of EX. But remember, this is not the variance that was asked. The variance is got by this formula. So what you have done, we have only got this part. So after getting that part, we can come and substitute to get the value of val x. Now before we go to the next slide to get the variance, let's see how much can be awarded for this slide. Now the slide M1 is for the definition of EX squared and integration. So it's given at this point. Then B1 for substituting limits and the output. So these have to be seen for you to get that B1. So now that I've got EX squared, I'll go now and substitute to get my variance. So variance is given by that formula. We saw that EX squared is 4 over 3, and we also saw that the EX is, remember, is the expectation which we got in Roman 1, and it was 16 over 15. But remember, this formula says that the entire EX is squared, so that's why you put in brackets and you square the whole of it. So next is to use the calculator, and you'll come up with the answer as 44 over 225 as your variance. So lastly, we shall go to standard deviation. Standard deviation, remember, it is the square root of variance. So this is the variance, get the square root, and that will be the standard deviation. So basically that's what they wanted. Now let's see how marks can be awarded. So this M1 for substitution, A1 for the output, M1 for putting the variance under square root, and A1 for the output. So basically those are the 5 parameters which we cover in subsidiary math under continuous probability. We cover individual probability, total probability, mean, variance, and standard deviation. So we have covered all the 5 parts. What we are left with is to look at the UNEB questions, or questions that have appeared in the previous past papers of UNEB Subsidiary Mathematics under the topic of continuous probability distribution. We shall start with this question. So question 4 came from UNEB of 2017, question 13 in Subsidiary Mathematics. So it says that a continuous random variable capital X has a probability density function PDF given by, so this is the function and this is the range. 0 elsewhere, like I said, elsewhere means that any value of X which is not in this range has a 0 probability or 0 function. The function is 0. Where K is a constant, determine part A, value of K, part B, probability of X greater than 1, part C, expectation EX, and part D, variance val X. So remember, K is a constant, and like we said, when they want the value of a constant, you have to remember the concept that total probability is equal to 1. So that is where we're going to start from. So you have said that for when they want the value of K, total probability must be equal to 1. So fx was already always given in the question, and all x, it depends on the range of values given in the question still. So when you go back to the question, you realize that fx is this. So this is your function, and the range of values of x are these ones. So all x means that you're going to integrate from this smallest one to the largest one, which is from 0 to 3. So let's substitute that in this expression. So when I substitute, fx is that, and all x means that you're integrating from 0 to 3, but always remember to put equal to 1. Most students forget to put this equal to 1, so it has to be seen. Then this k is a constant, can come out. Now I'm going to integrate this. So x squared, when I integrate, remember this power is 2, so increase the power by 1 is 3, divided by the new power, which is this, to give you a third x cubed. Then this x is a constant, so when I integrate a constant, I'll get that constant with x on it. So 6 becomes 6x. Now these limits are still put here. Now we have integrated. Next is to substitute the limits. So when I substitute, remember we begin with the upper limit. So when I put this 3 here and here where there is x, I come up with this. And when I put this 0 where there is x, I'll come up with 0, which is that. But remember there is k outside, so k has, that's why I multiply this by k. Also here, k times 0 is 0, that's why here you only see 0. So next is to simplify still. 9 plus 18 gives you 27, but there is k here, that's why you see here 27k equal to 1. But remember they want the value of k, so divide both sides by 27 to come up with k equal to 1 over 27. So that's the value of k, and that means that then now the function is going to become 1 over 27. Remember the function here, it was k, but since we have got the value of k, we are going to replace it here to get a function without where the unknown constant has been substituted. So in the end, this is our function that can be used to answer the preceding questions. So that was part A. Now when you go to part B they want the probability of x greater than 1. What does that mean? Like I said, x greater than 1 means that 1 is the smallest, so 1 or more. Now the question is, where do you stop? You stop at the largest value. Therefore you're going to integrate from 1 up to the largest value, which is 3. So let's do that. So here we have said that probability of x greater than 1 is equal to the integral of this function here, which is there. I think you see that this is a constant, so it can be put outside the integral. Then this one is here. Then you integrate from 1 up to 3, because 3 is the largest value here, and 1 is what was given in the question. So when I integrate, the formula still remains increase the power by 1 divided by the new power. So integrating x squared gives me a third x cubed. Integrating 6 gives me 6x. The next is to substitute the limits. So when I substitute 3 where there is x, I'll come up with this. And when I substitute 1 where there is x, I'll come up with that. So when the next is to use a calculator. When I use a calculator, the whole of this box bracket, everything will give me 62 over 3. Then there's this 1 over 27 which is maintained. Then when I multiply these two, I'll come up with 62 over 81. So you can stop here, or you can still use decimals as long as they are 4 decimal places. So basically that's what they wanted in part A and part B. Now let's see how marks can be awarded for these parts. So M1 for definition of total probability, this equal to 1 must be seen. Then another M1 for integration, M1 for substituting limits, and A1 for the value of K. Here M1 for definition of probability and integration, so it's given at that step. M1 for substituting limits, A1 for the output. So that was part A and B. Now part C and D, they want expectation and variance. So you have so that expectation EX is equal to the integral of x fx. So always remember that EX is x fx. Next we shall substitute. Now the function was x squared plus 6. Now when I multiply x through x squared plus 6 gives me x cubed plus 6x. But there was also 1 over 27 which was outside, so which was a constant, so it is there. Then I integrate from 0 to 3. Now why is it 0 to 3? Because all x means we integrate for the given range. So when you look at the question, the range is from 0 to 3. That is why you have to integrate from 0 to 3. So when I integrate, I'll come up with this gives me a quarter x power 4, and this gives me 3x squared. Why? Because this would have been 6x squared over 2. Now 6 over 2 gives me 3. That's why you see here 3. So next we substitute the limits. Begin with the upper limit. When I substitute 3 here and here, I'll come up with this bracket. When I substitute 0 here and here, I'll come up with 0. So next is to use a calculator. So this bracket alone gives me 189 over 4, multiplied by this 27 to come up with 7 over 4. Which is the expectation. So that was part C. Now we shall go to part D, where they want variance of x. So variance of x is given by this formula. So the good thing is that we know this EX, which is that, but we don't know EX squared. So what we are going to do, we are going to first find the value of EX squared. Like I said, the easiest way to memorize the formula is that when this is squared, even here you put x squared. So when I multiply fx by x squared, I'll come up with this function, and the constant is still there outside. We are integrating all x, meaning it has to be from 0 to 3, because 0 to 3 were the given interval in the question. So when I integrate, x power 4 gives me a 1 over 5 x power 5. Then 6x cubed x squared gives me 2x cubed. Next is substitute. When I substitute this 3 here and here, I'll come up with this bracket. When I substitute 0 here and here, I'll come up with that 0. When I simplify further, this bracket will give me 513 over 5, and when I multiply these two, I'll come up with 19 over 5, which is 3.8. So that is EX squared, but remember this, that is not the answer to the question. The question wants variance. So what you have to, after that we have to remember that variance is EX squared, where EX squared is this, and that is what we put here, minus EX everything squared. So EX is here, so that is what we put here, but remember we said everything is squared, so that is why you put a square there. Now next is to use a calculator. When I use a calculator, this gives me 0.7375. 1.5 to 4 decimal places. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for definition of mean, which is there, M1 for integration, M1 for substituting limits, A1 for the output. Then here M1 for definition and integration, so it's given at that step. Then B1 for substituting and limits, so these two must be seen. Then M1 for this substitution into a formula for variance, and this A1 for the final answer which is required. So that was question 4. Now we shall go to question 5. Question 5 came from UNEB 2016 question 13 and says a random variable capital X has a probability density function fx given by that, where k is a constant. Determine part A value of k, part B probability of x greater than or equal to 1 but less than or equal to 1.5, and part C expectation ex, and part D variance var x. So just start with the part A where they want the value of the constant, and like I said, each time they ask for the constant, what you need to remember is that total probability is equal to 1. So function is this, and the limits used will be these two from 0 to 2. So let's go and substitute that. So total probability is always equal to 1. So when I substitute for fx is that, and all x means integrate from 0 to 2 because that's what was given in the question, and always remember to put equal to 1. Most students forget it. Then you can't integrate when there's this product, so we have to bring this x inside. So when I bring it inside, I'll come up with x squared plus 2x, and this is a constant, can come out, but remember it is equal to 1. The next is to integrate x squared. Integrating it gives me a third x cubed. 2x integrating it gives me x squared. The next is substitute limits. 2, I'll get this, and the one I substitute for 0, I'll come up with that. But remember there is a k outside, so when I use the calculator still, this bracket gives me 20 over 3, but there's a k, that's why there is 20 over 3k, and yet it's equal to 1. So when I make k the subject, I'll come up with 3 over 20 as my value of k. So basically that's what they wanted in part A. Now let's see how marks can be awarded. So M1 for the definition of total probability, M1 for integration, M1 for substituting limits, A1 for the value of k. So that was part A. Now shall go to part B, where they want you to get the probability of x greater than or equal to 1 but less than or equal to 1.5. Now here, like we saw under the formula for individual probabilities, it means that we are going to integrate fx. This is fx from what? From 1 up to 1.5, because both limits have been given. So this is a new function where with k being substituted. Therefore, for the given required probability, they want probability of x greater than or equal to 1 but less or equal to 1.5, meaning that we're going to integrate from 1 up to 1.5 of this fx which is there. So when I integrate, first of all, this is the constant, so it can first come out. Then when I integrate this, x squared gives me a third x cubed, and 2x gives me x squared, and the limits are from 1 to 1.5. So next is to substitute the limits. So when I substitute 1.5 where there is x, I come up with this bracket, and when I substitute 1 where there is x, I come up with that bracket. The next is simplify. When I use a calculator, this bracket will simplify to 27 over 8, and this bracket will simplify to 4 over 3, but there is this 2 over 3 over 20 outside. Then when I simplify the whole of this, I'll come up with my answer as 49 over 160, or I can put in decimals to become 0.30625. So basically that's what they wanted in part B. Now let's see how marks can be awarded. So M1 for definition and integration, so it's given at this step. M1 for substituting, A1 for the output. So that has been part B. Now part C, they want expectation. So you have to remember the formula for expectation. EX is given by the, like I said, the easiest way to remember, when there's X here you should add X. So when I substitute, I'll come up with X fx gives me that. But I can't integrate when this X is here, so I have to put it inside the bracket. So to come up with that step. So at this step now I can integrate. So when I integrate, x cubed gives me a quarter x power 4, and 2x squared gives me 2 over 3x cubed. The next is substitute. So when I substitute the upper limit, this, put it here and here, I'll come up with this bracket. Then this 0, put it here and here, I'll come up with 0. So when I simplify this bracket, I'll come up with this, and in the end I'll come up with my final answer as 7 over 5, or 1.4. So basically that's what they wanted in part C. Now let's see how marks can be awarded. So M1 for the definition of expectation, M1 for integration, M1 for substituting limits, A1 for the final answer. So lastly, they wanted variance of x, but remember variance is given by that formula, ex squared minus ex everything raised to the power 2. But we know this one because we have got it in part C, that is mean, but this one we don't know it yet. So what we are going to do, we are going to first get this value of ex squared, and like I said, the easiest way to memorize, if this is x squared, this is also x squared. So next substitute, this is this, and this is the whole of this with this constant. So I can't integrate when this is here, so I have to put it inside the bracket. So when I put it inside the bracket, I'll come up with that. So now I can integrate. Integrating x power 4 gives me a 1 over 5 x power 5. The integrating 2x cubed gives me 2 over 4 x power 4. The next is substitute the limits. So when I substitute 2 where there is x here, I'll come up with this bracket, and when I substitute 0 here, I'll come up with this 0. The next is to simplify. When I simplify, this gives me 32 over 5, this gives me 8, and the whole of this gives me 54 over 25, or 2.16. So any of these two is okay. But remember, that is not the final answer. So the final answer is this, because this was just ex squared, but the question wanted variance. So I have to remember that variance is equal to ex squared minus ex everything squared. So ex squared is this, so I'll come and put it here, and ex was got in part C and it was 1.4, so I have to square it to come up with 0.2 as my variance. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for definition of ex squared and integration, so given at that step. B1 for substituting limits and output. Then M1 for the substitution, and A1 for the final answer, which is required. So that was question 5. Now we shall go to question 6. So question 6 came from UNEB 2015, question 13, and says a random variable capital X has a probability density function given by fx equal to this, so kx over 6, and the interval is that, where k is a constant. Then part A, find Roman 1 the value of k, Roman 2 the probability of x greater than or equal to 1.5, and Roman 3 the mean of x, which is ex, and part B, sketch the graph of fx. So we shall start with part A, where they want the value of the constant, and like I said, for you to get the value of constant, you must remember that total probability is always equal to 1. So the function to integrate is this, which is given the question, and the limits to use are these ones. So we are going to integrate this from 0 to sorry, from 1 to 2. So I come and say that total probability is equal to 1, then I substitute the function was kx over 6 and the limits were from 1 to 2. So you should remember to put equal to 1. The next is to integrate. When I integrate this k is a constant, can come out. So this becomes 1 over 12 x squared. So how does 1 over 12 come about? So remember, this is x, so integrate the power by 1 becomes x squared. Then divide by the new power, it means you bring the 2 down to become 6 times 2, which gives you 12 there. So you have to remember to equate to 1. So next is to substitute the limits. So when I substitute this 2 here, I'll come up with this bracket. When I substitute this 1 here, I'll come up with this bracket. So next is to simplify. This bracket gives me 1 over 3 and this bracket gives me 1 over 12. Then when I simplify further, 1 over 3 minus 1 over 12 gives me 1 over 4. But there's a k here, so it has to be maintained. Next is to make k the subject, and k will be equal to 4. So that was Roman 1. Next is substitute. Remember, the function was kx over 6, so where there is k we shall put there 4. So now we shall go to Roman 2, where they want the probability of x greater than or equal to 1.5. So the probability means that you integrate from this one up to the highest value, which is 2, of this function which is there. So when I integrate that function, I'll come up with that. And when I simplify and when I substitute the limits, I'll come up with that. Then when I use a calculator, I'll come up with the answer as 7 over 12. So basically that's what they wanted in Roman 1 and Roman 2. Now let's see how marks can be awarded. So M1 is for the definition of probability, total probability, and M1 for integration, M1 for substitution, A1 for the value of k. Then here, definition of probability, then integration, substitution, and output. So Roman 3, they wanted the expectation. So remember that expectation, when there is x here, you have to put x there. That's an easier way to memorize. So you are going to substitute to come up with 4x squared over 6. All x means from 1 to 2, because these are the given limits in the question. So when I integrate, I'll come up with 2 over 9x cubed. And then I substitute the limits to come up with that. Then when I use a calculator, I'll come up with my answer as 14 over 9. So that was Roman 3. Now we shall go to part B. Part B, they wanted us to sketch the graph of fx. Now for you to sketch, you have to find the boundary values. For example, when you go to this question, if you look at this, so you must get the value of fx when x is 1 and also when x is 2. Now when x is 1, it means we put 1 here to come up with 4 times 1 over 6. And when x is 2, it means that you push 2 here to come up with 4 times 2 over 6. So that is where this is coming from. Here f1 is 4 times 1 over 6 and f2 is 4 times 2 over 6. So after getting those points, you are going to draw your graph. So the first thing to do is to draw the axes and label them. So horizontal is x and vertical is fx. The next is to demarcate the values. So in this we have for the values of x we have 1 and 2. That's why you see here 1 and 2. Remember, they want a sketch, so you only put the values which are vital. But for the vertical we have this and this, so that's where we put here. So this one is there and this one is there. The next is to plot. For example, the 1 corresponds to 2 over 3. That means that this is 1 point. Then 2 corresponds with 4 over 3, so this 2 corresponds with this to come up with another point. So next is to join from here up to here using a ruler. So let's first do that. So 1 is there and 2 is there, then we join using a ruler from here to here. After that, we have to label your graph. So you have to label your graph by writing there the given function. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for the definition of EX, M1 for integration, M1 for substituting limits, A1 for the output. Then B1 for getting both values of F1 and F2, B1 for axes which are well labeled, and B1 for the graph which is also well labeled. So that brings us to the end of this video. Thank you for watching, and be reminded that the next video will be on normal distribution. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on normal distribution has been uploaded. And also, if you know any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that you can all benefit as a family.